For this video, we are going to continue with a very important formula, and we call them as the scalar product or the dot product. Alright, so for the learning outcome for this part, generally you need to calculate the scalar product of two vectors. And after that, you need to use the scalar product to determine the angle between two directions vector, right, to solve problems concerning perpendicularity of the vector. Right, so the main idea that we are talking about for this whole video is about the scalar product and also angle. Okay, so what is scalar product? So scalar product generally have another name. We call it as dot product. So please remember this word. They are the same. All right, so scalar product or dot product means something like this. Okay, if let's say I'm having a vector A, which is equals to 1, 2, 3, and also a vector B, maybe which is equals to 2, 1, negative 3, let's say. Okay, then we want to find out the scalar product between these two vectors means that A dot B. So the symbol is something like this. So this one we call it as dot lah. So that's why we call it also as dot product. Alright, so how are we going to carry out the dot product? So generally, you are going to multiply the x with x, y with y, and also the z with z component. So as an example, you are having 1 multiplied with 2, you get a 2. 2 multiplied with 1, you get a 2 also, and then you add them together. And after that, 3 multiplied with negative 3, you get negative 9. Right, so 2 plus 2 minus 9, you get a negative 5. So when you apply dot product for two vectors, the final answer that you get is not a vector, but it is a number. So this number, you get a number, right, at the end. So number we also call it as scalar. That's why we have the name of scalar product. Alright, so just now I already carried out the dot product. So generally you need to know x multiplied with x, y multiplied with y, and also z multiplied with z. So that's why we call it as scalar product or dot product. Okay, alright, then after that, from scalar product or dot product, they try to we try to apply it in a formula so that we can find out the angle between two vectors. So there's one important formula, which is this one, that involve a dot product on the left hand side. Okay, so this is a super important formula that you need to always remember that. Alright, so for those who are interested to know how we derive this formula again, you can go online and search for it. So for us, we are not going to discuss how we get the formula. I'm just going to show you how we apply it, okay, to find out the angle between two vectors. Okay, so you can see that for this formula, A dot B on the left hand side. So left hand side will be a scalar product for vector A and B. And after that, right hand side, you have modulus A, modulus B, multiplied with cos theta. So what is the meaning for cos theta here? So the cos theta, the theta actually means the angle between the two vectors A and B. Okay, so one thing to remind you again, like as what I mentioned before, right? If you have vector A and you want to find out the angle between vector A and B, you have to make sure that both of them are starting from the same point. See that? So this is B. And therefore, the angle that you get should be this one. This one will be your theta. Okay, so always bear in mind that when you want to find out the angle between two vectors, this is the correct value. If you want to find out the angle between this one and also this, let's say you're having A and you are having B, this is not the theta. Alright, so if you're having A and B, when you apply this formula, the theta is actually this one, but not this. Okay, because both vectors should come out from a same point. That only they can form a theta. Please always remember this one as it is a very important small details. Okay, so this is the important formula that we use it, okay, to find out the angle between two vectors. And mainly the left hand side will involve the scalar product or the dot product. Okay, so if we proceed further, you will see that there are some properties of the scalar product for any vector A, B, and C, and N is a scalar. Alright, so I'm not going to show you everything here, but maybe I just show you one property. Okay, so this is one of the property A dot A equals to modulus A squared. What does it mean? Alright, so it actually means like this. If let's say I'm having A, which is equals to 1, 2, 3. Okay, so for the left hand side, I'm having A dot A, right? So A dot A means 1, 2, 3 dot 1, 2, 3. And I'm having 1 plus 4 plus 9, which is equals to 14. Okay, and then what is right hand side? So the right hand side means that I'm having modulus A. So modulus A means that square root 1 square plus 2 square plus 3 square, and then I square the whole thing. I square the modulus of 8. So you'll see that I'm squaring the square root of 14. And the final answer is equals to 14. So that's why left hand side and right hand side having the same value, right? So which means this is the correct property. Okay, so usually for properties, right, you don't need to learn how to prove one. Just that if you want to understand, you can use a simple vector like this to prove for understanding. Okay, all right. So I'm not going to go through with all the properties here. All right, but I'm going to discuss two important results here, and I think that it is worth for you to remember it. Okay, so which is part F and also part G. Okay, so let's have a look for part F and part G. Part F, A dot B equals to modulus A modulus B if and only if A is parallel to B and the theta is 0 angle. What does this mean? Okay, so for F, part number 1 here, the first part of F, A dot B is equals to modulus A and modulus B. Original question will be cos theta. Alright, cos theta. And then because of here they say A and B are parallel, right? So when A and B are parallel and the theta is 0. So when theta is 0 means this. If I'm having an A in this direction and I have the B also in the same direction, which is parallel, and then for this case we call it as theta is equal to 0. That means the angle between A and B is equal to 0. Okay, so when we are having A dot B, it is equals to modulus A modulus B cos 0. So cos 0 is equals to 1, right? So eventually you will get this. Okay, so in the question, if they mention parallel and same direction, I think same direction must be included because parallel can be same direction or different direction. So parallel in same direction, then you can use the result A dot B equals to modulus A modulus B. If they only mention parallel, but they didn't mention whether are they same direction or opposite direction, then you use the previous method that we used in the previous video. Okay, which means you write U1 equals to lambda U2. If they didn't mention whether are they in the same direction or not. But if let's say they mention clearly parallel with same direction, then you can apply this formula. Okay, so the second one will be A dot B equals to negative A negative modulus A modulus B if and only if B is in the opposite direction, where it means that the theta equals to 180. So again, what does this mean? So this one, it means that you are having a vector A and then they are having a vector B. Okay, but in a different direction. So for this case, generally the theta is this one, which is theta equals to 180. So very obvious, you can see that they are in different direction, opposite direction. Right, so when you're having opposite direction means that you substitute the cos theta, the theta as 180. So cos 180, you get negative 1. And that's why eventually you get A dot B equals negative modulus A and modulus B. So again, you can only apply this formula when the question mentioned that they are parallel and is in the opposite direction. Okay, so these are the two different cases here. And the third one will be A dot B equals to 0 when A is perpendicular to B. Okay, so again, this is a very important formula that we often use in. So in the question, when you see the word perpendicular for both vector, then you can use this result, which is A dot B equals to 0. Alright, so I think very obvious already. The perpendicular case, A is like this, and then B is in this direction, and then it is 90 degrees to each other. Okay, so again, this result also comes from this original equation. Cos 0, you get, cos 90, you have a 0. That's why A dot B equals to 0. Alright, so to me, these three are something quite important and it is worth for you to know about it. Okay, especially the perpendicular result. Right? Okay, so we can now discuss some example on all these results. Okay, let's have a look for example 8. So they give you three vectors here, vector A, vector B, and also C. So they want you to find the value of P for which B and C are perpendicular. Alright, so since they said B and C are perpendicular, you can straight away apply the formula where the vectors are perpendicular one. So you can write it as B dot C, it is equals to 0 because you know the word perpendicular, right? So you straight away apply the formula for the perpendicular result. Okay, so B is 2, 6, and 3 multiply with C. So it's P, and P plus 1 and it becomes 0. So you apply the dot product 2P plus 6P plus 3P plus 1 which is equals to 0. And then if you continue to simplify everything to get a P, your final answer for P should be equals to negative 3 over 11. So this is how you get the constant, the value of P by using this information given in the question, which leads you to this formula as a result. B dot C equals to 0. I think it is not hard to understand, right? It is quite simple as long as you know how to link the word perpendicular with the result formula B dot C equals to 0. Okay, so this is what you have for example 8. Then we continue to example 9. Okay, so for example 9, to me, I think it is not hard also. So I will just roughly guide you how to do it, or if you want, you can try to pause the video and you try it out on your own first. Okay, so here they tell you that the position vector for point A, B, and C are these. So this is OA, this is OB, and OC. Find the alpha if OC is parallel to BA. Okay, so first of all, I think I need to find out what is BA first. So I will try to find out BA first. So BA, according to our basic knowledge on vector, it should be BO plus OA. So how to get BO? So BO should be negative 5, 3, negative 6 plus OA. So what is OA? 3, 4, and negative 5. If you didn't do any careless mistake, you should get negative 2, 7, and negative 11. So this is BA. Alright, so to answer the first part, they say OC is parallel to BA. They only said the word parallel, but they didn't say whether are they in the same direction or opposite direction. So you cannot apply the result that we have on top here. Okay, so to me, if you want to apply these two results, it must mention very clearly whether are they in the same direction or in the opposite direction. But for this case, they didn't mention anything. Therefore, if you want to use the info parallel to BA, then you should use the result that we learned in the previous video, which means you can write it like this. OC is equals to KBA. Because you know that if let's say two vectors are parallel to each other, then they can be written in the multiple of each other, right? So A equals to something B, lambda B or whatever. Okay, so if you have OC equals to KBA, what is OC? So OC is alpha, 5 minus alpha, alpha minus 9, which is equals to KBA. So KBA means you should have -2, 7, -11. Okay, then from here, you multiply the scalar k inside into the vector BA, and therefore you have -2k, 7k, and also -11k. So in this question, they want you to find out alpha, right? Okay, so to find the alpha, you can see that there are two unknown here, like alpha and also the k. So to solve for two unknown, you need two equations. You have more than enough here because for x component, you compare it with x component. So the first equation that you can get is alpha equals to -2k, which is the first equation. And you compare maybe either y or z, up to you. So maybe you can compare the y, which is 5 minus a equals to 7k, and this is the second equation. You want to use the third one also can, the first and the third or whatsoever, as long as you use two of these equations, and then you continue further. Eventually, the alpha that you get should be equals to -2, if I'm not mistaken. Yeah, -2. Okay, but of course, in your solution, don't just put it as dot, 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 dot. I want you to complete the steps and then try to get the final answer, which is alpha equals to -2. So this is how you solve it. Then for part number B, how can we solve for part number B? Okay, so part number B, they say that OC is perpendicular to BA, so which is quite straightforward. So you write OC is equals to BA. Therefore, OC dot BA it is equals to 0. So this is the this is the formula for the perpendicular vectors, right? So what is OC again? Alpha 5 minus alpha, alpha minus 9 dot BA, which is -2, 7, and -11, and it is equals to 0. Continue from here, you should able to get alpha is equals to 6.7. Alright, so you can see that for these two examples, we are using some words, the keyword of parallel and perpendicular, and we try to apply the formula that link to these two concepts and to answer the question. Okay, so this is what we have for this video to discuss about the info given as parallel or perpendicular vector, and then we apply the formula to get the solution, to get an answer. So in the next video, we will focus more on finding out the angle between two vectors. Alright, so we will discuss this in the next video.